Hello, my name is Travis Guy Nickham, and my molecular villain of the year is tetraethyl lead. What is tetraethyl lead exactly? It's a type of compound called an organometallic compound, which has a central lead atom. Attached to tetraethyl lead's central lead atom are four carbon atoms, and attached to each of these are three hydrogen atoms, which make a total of 20 hydrogens. It is tetrahedral in shape, with a D2D point group symmetry, with three reflection planes and three twofold rotation axes. It is a colorless, viscous liquid with a sweet, pleasant, or musty odor. It is highly volatile and combustible with 200 degrees Fahrenheit, 93 degrees Celsius. It is soluble in gasoline and organic solvents, and it decays into toxic products under high temperatures. It violently reacts with strong oxidizers, acids, and halogens, and attacks some plastics, rubber, and coating forms. It has a boiling point of approximately 392 degrees Fahrenheit or 200 degrees Celsius, and a freezing point of negative 202 degrees Fahrenheit, negative 130 degrees Celsius. It has no known enantiomers. The reason why I made this the molecular villain is because it is highly volatile and lipophilic, or fat-loving, and interacts with fat molecules a lot, but the fat molecules gain no benefit from it, so this can lead to a loss of bodily functions, and it can cross the blood-brain barrier easily. For those with acute exposure, early symptoms may include eye and skin irritation, sneezing, fever, vomiting, and a metallic taste in the mouth, while later they may experience pulmonary edema, anemia, ataxia, convulsions, high weight loss, delirium, irritability, hallucinations, nightmares, fever, muscle and joint pain, brain swelling, comas, and cardiovascular and renal organ damage. Meanwhile, for those with chronic exposure, they may experience memory loss, delayed reflexes, neurological issues, insomnia, tremors, psychosis, attention loss, and a lowering of IQ and cognitive function. We can, it can also cause carcinogenity and birth defects. For a little history on this molecule, it gained some wide use in the 1920s after being found by Thomas Midgley Jr. to be a useful anti-knock additive to gasoline in 1921. It, it was marketed under the name ethyl to avoid concerns over it being a lead product. It gained widespread use and led to the building of stronger, higher compression engines. A scientist named Cameron Patterson eventually discovered high atmospheric lead contamination while trying to find the age of the Earth. He also studied ice core samples and found that their lead content dated back to when tetraethyl lead was first used, and he used this to bring lawsuits against corporations. Today, tetraethyl lead is currently used as airplane fuel. Some similar molecules to tetraethylene include metallic anti-knock agents, or organometallics, which form a protective layer and prevent pre-ignition through metallic deposit formation, and are thus the closest to TEL in function. Oxygenates and others, which boost octane's oxygen content for clearer combustion. And finally, hydrocarbons and aromatics, which help get rid of knocking without adding metals. Thank you for listening to this presentation.